One of the most frequent performance problems your users will notice is how your app reacts when moving from a great network connection to a bad one. My name is Colt McCandless, and if your app isn't properly adapting to network latency during the day, your users will blame your app rather than their connection. The truth is that the internet is made of a bunch of crazy moving parts, or a series of tubes if you're a senator. Anyhow, basically, requests made from your phone have to hit a local cell tower, which then gets routed to the service provider server, and then it may hit a local data proxy for that provider before going out onto the internet and connecting the main data server, which then needs to decode the response, fetch the data, and then send that back, only to return the data back to your cache's ISP server and then finally to the phone itself. Basically, it's a lot of moving parts, and a bottleneck can be anywhere. And since you don't control all those stages, the best you can do is make sure that your application properly adjusts to how it works based on the connectivity of the device. This involves two things. Number one, getting information about the speed and performance of the network, and number two, designing your app to respond to changes in bad latency environments. Now, the first is easier to do than you might think. Simply grab the connection manager and determine if you're on a mobile network. From there, a quick call to grab the network subtype gives you an enumeration for what type of network you're connected to. A handy lookup table then lets you know what kind of network you're dealing with and what to expect as the best possible bandwidths and latency. But in truth, that value gives you the best case scenario. See, in the wild, you're going to get much worse results. Even though your user might be on an LTE network, there may be a problem with a slow data server, resulting in maybe double the time it would normally take on that network for that request. So a more accurate, although more complex solution is to evaluate the time it takes to grab responses from your network. For example, if you know that all of your thumbnails in your list view are 128 by 128 pixels, then you have a general sense that should be about 1K inside, which should, on the given network, only take a certain amount of time to download. You can then average the true cost of these fetches over time to give you a better sense of what the real network conditions are and how they are changing as the user moves through their day. Once you get this information, you then need to decide how to design your app to handle it. As a simple approach, you can define 2 thresholds and 3 buckets of classification. If your latency is less than, say, a lower threshold of 60 milliseconds to fetch an asset, then your user is on a great connection. You may be able to be more aggressive about the amount of data that you prefetch and less aggressive about things like caching. However, if it takes less than the upper threshold, then you may not be in the best spot. So you need to become more aggressive about batching and caching and take advantage of how often you request data. And if they're above the max threshold, well, then you should find ways to defer requests until later, when there might be a better network connection, or change the UI so that not fetching all the thumbnail images isn't such a huge jarring problem. But the truth is that these thresholds won't work for every user. In fact, you're going to need to put a bit of elbow grease in and define the correct thresholds for the 50th percentile, 90th percentile, and 99th percentile of the connections that your users are actually on, which is actually a pretty large engineering project, but critically important for your app to remain responsive and magical in high latency environments. Now, rather than waiting for the users to focus on slow connections to complain, it's better to start designing and testing bad bandwidth on your app early. You can test how high latency impacts your applications by throttling the bandwidth when you're running the Android emulator, or you can check out third-party apps like AT&T's Network Attenuator. In both cases, you can see how your app responds when latency goes sky high, which you should be doing with everything, honestly. Testing performance on the slowest hardware, worst networks, and most insane conditions is the best way to ensure stable, consistent performance for your users. Of course, you'll need to watch the rest of our Android performance patterns videos to see what to fix, and join our Google+ community to get advice from other developers in the same boat. Trust me, your users will thank you. So keep calm, profile your code, and always remember, perf matters.